Hi, my name is Wayman Kwon, creator of the WNK Math channel. In this video, I am going to talk about Introduction to Equations. This is the second part of a two-part series on Introduction to Equations. Now, by the end of this video, you should be able to answer these questions. What are the key ideas of solving an equation? How do you manipulate an equation in order to solve an equation? Now, these ideas should be familiar to you if you watch part 1, but I'm going to review them because these are important ideas that will build in understanding of equations. Now, the first point is we want to think of equations like a scale balance or seesaw. We saw how equations actually mirror these scale balance and seesaw, not only the way it's built, but the way we manipulate these things. The second point is that there's a pivot point that separates the left side and the right side. In an equation, this pivot point is represented by the equal sign. And in scale balance, it's usually where the tipping point of the seesaw is, usually at the center. Third point is that we can manipulate equations by performing math operations on either side of the equation, or we can think of it as adding or subtracting weight in the scale balance. We saw that we can simply manipulate one side of the equation, but it becomes unbalanced. We can restore this balance by either undoing the changes or performing the same manipulation on the other side. Let's take a look at that idea a little bit closer. Now we see that in this example here, we started with 10 equals to 10. We added 5 on the left side, which resulted in the scale balance to be unbalanced. In this case, it's a seesaw. And we have two ways of restoring balance. We can either undo the changes, as you can see in red, where we cross out everything and becomes back to the original, or we can add 5 on the opposite side because we added 5 before, and we reestablish balance this way. Now, the question we would like to ask is, which type of manipulation to rebalance the equation is much more useful? Is it the undoing the changes, or balancing it by doing the same manipulation to the opposite side? It's the second one, of course. By undoing the changes, we actually get back to where we started, which really does not advance our cause. It's like we're going back in circles here, and it doesn't, move us forward. By doing the manipulation on both sides and keeping it balanced, we actually change the way our equations look, and we actually advance our cause, which actually leads us to this first idea of solving equations. Whatever you do to one side of the equation, you do to the other side of the equation. Now, in this particular example, we start with 10 equals 10. And if we were to manipulate the left side, say we added plus 5, in order to ensure that it's balanced, we add 5 to the other side here. Not only that, this kind of changes the complexity of our equation so that it looks different, but it keeps balanced. This is a really important fact about how we're going to solve equations. We've got to make sure that things keep equal, or otherwise we'll be manipulating and we'll be going nowhere. Now let's take a look at key idea number 2. Whenever we're asked to solve an equation, it usually means that we want to isolate the variable to one side of the equation. Of course, using equation manipulation. What does that mean? It means that we want to get x by itself on one side, or whatever variables you've encountered. So that means that we have x by itself on our first example, x equals 3, x is by itself on the left side, and we have all the numbers simplified on the right side. Or you can have it the other way around, where you have all the numbers on the left side and the variable, in this case b, all the way on the right side, all by itself. Now we see that how it means to be isolated. Let's see examples of what it means when x is not isolated. Our first example, x plus 3 equals 7. We could see here that on the left side, x is not by itself. It's added by 3. Example number 2, x minus 7 equals 6. We see that x is not by itself. It's being subtracted by 7. So it's not isolated. Our third example, 2x equals 12. Is x actually isolated here? Absolutely not. We see that x is multiplied by 2 here, so it's 2x, not a single x here. Finally, we have x divided by 3 equals 6. X is not whole, so x is not by its lonesome self. We gotta get x so that it's x only, not x divided by 3. All these cases, these are simple cases where x is not by itself. We want to get to x equals to, or something equals to x. That's our goal. That is our goal. I'm sorry. That's our goal. That's how we solve an equation. That's what we do when we're asked to solve an equation. Get x by itself. Now we'll actually use all 4 of these examples to show you what to do to get x by itself. Let's visit our first example here. X plus 3 equals 7. What do we do here? How do we manipulate this so that we can get x by itself here? Now we see that x is bigger by 3. So it's x plus 3. So we need to get rid of the plus 3 in order to isolate x. How do we get rid of the plus 3? Well, think of it as 3 is being, it's a little bigger. So when it's a little bigger, we subtract. So in this case, if we have a plus 3, we use minus 3 to get rid of the plus 3. Because plus 3 minus 3 equals 0. But notice that we made the manipulation minus 3 on the left side. If we made that manipulation on the left side, to make sure we have balance, we must subtract 3 on the right side. So if we simplify everything, we have x by itself on the left side, we have 7 minus 3 on the right side, which gives us 4. Which our final answer is x equals 4. Let's take a look at our second example here. X minus 7 equals 6. Now how do we isolate x in this case here? We can see that we have a minus 7, next to the x. Think of it as x lost a few pounds and, it's a little bit skinny. How do we get x back to its whole self again? So we use the opposite operation of minus, which is plus. So in order to get rid of the minus 7, we add 7 on the left side. But if we add 7 on the left side, we have to reestablish balance again. So we have to add 7 on the right side as well. As a result, if we simplify this, we see that x is by itself on the left side, and we have 6 plus 7, which gives us 13 on the right side. And we get to our final answer of x equals to 13. Let's take a look at a third example here. 2x equals to 12. How do we think about this? We think of x, we want to get 1x, but we have 2x. So x is doubled its weight. You can think of it as doubled. So if something is doubled, we need to half it. So in other words, our operation here is we got to do 2x divided by 2. The entire left side by 2. But if we were to cut the weight in half on the left side, we have to cut the entire weight by half on the right side as well. So we divide 2 on the left side, we divide 2 on the right side. 2x divided by 2 results in x, and 12 divided by 2 is equal to 6. So our final answer in this particular case is x equals 6. Our final example, x divided by 3 equals 6. How do we think about this? Think of x as being divided into 3 pieces. So we only have a third of the x. We need to get to the whole x. What do we do here? We have to multiply the left side by 3 so we can get the whole x. But if we multiply the left side by 3, we must multiply the right side by 3 as well to ensure that we have balanced equation. On the left side, if we have x divided by 3 times 3, it results in x. On the right side, we have 6 times 3. 6 times 3 is equal to 18, which gives us the final answer of x equals to 18. Now, this concludes our video on Introduction to Equations Part 2. Now remember the key ideas of solving equations. We will be reusing them. It is make sure that whatever we do to the left side, we do to the right side. Key idea number 1. Key idea number 2, when we're solving an equation, that means we're isolating for x. Thanks for watching this video. If you have any comments or suggestions, feel free to write them below. You can email me at waymanquant87@gmail.com. Thanks for watching. Have a great night, and I hope to see you again next time.